Hello, my name is Steven, and welcome to the next tutorial where we are discussing installing the Abyss web server from Aprelium on Debian Linux. Now, we're not going to do that in this tutorial. In this tutorial, we want to take a look at the file system and permissions, something that you'll want to get your head wrapped around when you're working with Linux. Alright, so let's go ahead and log in here. I will log in as the root user. Alright, there we are. We're logged in. And one thing you'll notice is that this right here tells us what directory we're in. The first piece of information here is who we're logged in as, what user account at, and then this tells us the host name of the server. Because if you have 10 different servers and you're logged in remotely, you want to know which one you're working with. And then the colon, and then before the pound sign we have this tilde, and that tells us a directory that we are working in presently. And the tilde is a special directory. If we do pwd, it'll tell us the actual path where we're at, and you'll see we are in /root, so the root directory. And then the slash is the root of the file system, and that's the highest on the tree that you can go. So if we do that, now we are in the highest directory in the Linux file system, and everything descends off of the slash, the /. Okay, so we are now at the root of the file system. Now I'm going to go ahead and change my user. So I'm going to go ahead and log out and re-log in, and my username is just user. Hopefully that doesn't get confusing for you. And there we go. Now you notice I'm logged in as user. I'm going to go back to the root of the file system, and there's our directory contents, ls-al. ls is listing a directory. The -a will display hidden files. And what are hidden files? Hidden files begin with a period. And so if you minus the a, you don't include that, you won't see the dot or the double dot. And if I go to my home folder, which is a tilde, which now is home user, you'll see everything begins with a period. So if you just do ls-l, well, you'll see nothing, because there is nothing that is not hidden in this directory currently. Okay, well, I'll go back to the root of the file system here, and let's say I want to create a file, touchfile.txt. Can't do it. The reason is I don't have permission to create a file in this directory. Okay, so what are permissions and how do they work? That's what we want to talk about today and hopefully help clear up for you. Okay, first things first. Your permissions are here. Your ownership is here. This right here for directories will tell you how many files are in the directory. I think it includes the dot and double dot. Then right here, well, we actually don't have any regular files, but if we had a regular file and this number was higher than 1, it would mean that 2 files are hard linked to the same file, which that's more advanced information. We don't need to worry about this column here. Right here we have the bytes of each file, and directories kind of arbitrarily take up 4 kilobytes. And then you have the modified time of the file or directory. Okay, so permissions over here. You see the first slot here is a D. D means directory. It tells you what type of file you're working with. And as far as Linux is concerned, a directory looks like a file, although the permission slot, the first slot, will be a D. That tells you it's a directory. Next we have something called a link. The real file exists in /boot/ and you can read the rest of the file there. But it's linked to this file, and that's why the file size is only 29 bytes, and you'll see an L here, and that indicates that the file is a link. Now I'm going to go ahead and do a kind of secret command called SU. That stands for super user. And it prompts me for my password because I'm going to become root. So enter your root password, and look at that. I was user, now I'm logged in as root. Now I can accomplish this command of creating a file. Now we'll look at the directory contents again, and I created this file, the date and time, the bytes. There's no information in the file, so it's 0 bytes. And now you notice this is just a regular file. The first slot in the permissions is simply a dash. Regular files will begin with a dash. And then you have 9 slots here. They're broken up into 3 groups. You see RWX are the possibilities. The R means read permissions, the W is write permissions, and the X is execute permissions. If you had a PHP script and you have the execute bit set, and your PHP file will also tell you where the interpreter is, or where the PHP executable is, you can actually run a file like if I had test.php, you could run it just like that. The execute bit would have to be set for that to work. Now, why are there 3 different sets here? The reason is because you have an owner of the file. The owner is this column right here. This tells you who owns the file. And you say, what's next to it? That is the group ownership of the file. So if, for instance, you had 5 different people you wanted to give access to, but you don't want them logging in as your user, you can give them group permissions and put those users in the group that that file is set to. So if the group permission were, say, development, or dev, we'll just say dev, and you have 5 different users and they are all members of the dev group, then you can specify group permissions. So the first set of permissions is for the owner of the file. So if you create a file, your username will be listed as the owner, and you'll see your permissions. The file I just created as root, root is the owner, that's me. I have read and write permissions. This file is not a script, and so the default is not to give execute privileges, permissions rather. And then you have the group permissions. I can change this to a different group owner. Well, that's something we'll deal with in the next lesson. But if I were to change it, then whoever's in that group, well, in this case, would only have read permissions. They couldn't write to the file, and if it was a script, they couldn't execute it because there's no execute bit there. And the last set of permissions regards every other user. And sometimes we call that world. So for instance, this file is world readable. You might catch that vernacular somewhere out on the internet. That just means any user on the computer has the ability to read the file. And so very quickly, just to recap again, in the permissions area, the first character tells you what the file is. It might be a directory, it might be a link, and it could just be a regular file with a dash. And then the 3 sets of permissions, the first applies to the owner of the file, and then the second set of permissions applies to the group owner of the file, and the last 3 pertain to every other user on the computer. And so we call those world permissions because any user that logs in has these permissions regarding this file. Now, since root owns it and the root group only has read permissions and everyone else only has read permission, what I'm going to do is I'm going to go back to becoming the regular user, and I'm going to try to delete this file, and that's not going to work. And so I will go ahead and show you that. And one quick word of caution, being the root user, you could destroy your system by doing just something as simple as that right there. It may not even need the asterisk there. And so be very careful with the root user because you can fix anything on your system or you can destroy your system. All right. So I become the super user or root user by typing SU in my root password. To get out of it, I type exit. And now I'm back to being just regular old user. And there we go, we still have the file.txt, and I'm going to try to remove it or delete it, and that would be RM. And it's saying, do you want to remove the write protected empty file? I'll say yes, and there we go, can't do it, permission denied. That's because I don't have write permissions to this file. And furthermore, I don't have permissions in the directory. Now right here, we have the dot. Anytime you do a directory listing with the -A to show you hidden files, you'll see the dot. The dot means the permissions for this directory. And we'll discover what all these permissions mean in the context of a directory in a little bit. Okay, so I'm going to go ahead and remove this file, but I've got to become super user again to do that. Okay, now I'm back to being user, and you'll see that file is gone. Alright, so we removed the file. Now we're at the root of the file system. If you go into your user folder, you'll have full permissions. The tilde will take you to your home directory, and for any user on the system except for root, your home folder will be in the home folder, and then your username as the subfolder. So that's where we are. Even though it just says tilde, just remember that's the user you're logged in as, it's their home directory. That's what the tilde is. Okay, so in this directory, you see everything is hidden. So if I just do ls-l, I get nothing, or just straight ls, I get nothing. Now, I have ownership of this directory. It's my home folder. I have the group ownership to this folder as well. And so that means I have read permissions, write permissions, and execute permissions. Execute permissions, you'll notice it's given to everybody. Why is that? Well, in a directory permissions, the execute bit means that you can enter the directory. And I'm going to go ahead and show you that right now. I'm going to go ahead and become super user again. And you'll notice on all these directories we have execute permissions until we get to lost and found. Now, because I have execute permissions as root, I can enter this directory. Well, you notice I just typed just a couple letters, and Linux filled in or auto-completed the rest. That comes from the tab button. And so I just typed in LOS and hit tab, and it finished it out for me. Windows does that too, so you may already know that. Alright, so lost and found, there I am. I can get into the directory by cd or change directory because I have execute permissions. Now, if I try doing that as just the regular user, I try to enter lost and found, it will not let me. I would have to have execute permissions in order to get into the directory. Now, if I want to do a list of the contents of the directory, I have to have read permission on the directory. So if I have execute permissions, I can enter the directory. If I have read permissions, I can then list the contents of the directory. If I have write permissions, that means I can move files, I can copy files, I can create files. I have full ability to mess with the files in the directory. Now, you couldn't delete them if you don't own them. And so let me back up just a moment and say the files that you own, you can delete and you can move. All right, so let's go ahead and make a test directory. I'm going to do that with mkdir, or make directory. We'll just call it test. And very quickly, I'm going to give ownership, and again this is covered in the next tutorial. I'm going to give ownership to the owner user, or user account of user, and we'll just keep it with the root group user as the owner, and then I just need to tell it the test folder. And you'll notice the test folder, there we go, owned by user, and root has group ownership. Okay, so the owner, that's user, has read, write, and execute permissions. If you're a group owner, you only have read and execute. And then all others have read and execute. Okay, so I'm going to go back to being the regular user. I'm going to go to that folder, and just the dot and double dot's all you see. And I'm going to go ahead and create a file. And so because I own the file, I can do whatever I want with it. I can read, write. If it was a script, I could make it executable. Now, let's try something else. I'm going to give ownership back to root. And surprisingly, it doesn't let me do that. That's interesting. So I have to do this as root. And done. Now I'm going to use the su command, and then if you specify a user account after it, you become that user. And because I'm springing into user account from root, you never have to enter a password for that username. Okay, so you'll notice that this directory is now owned by root, and that means that I don't have ownership privileges as user. I don't even have group ownership. So I'm stuck in this permission set to read and execute. So I can get into the directory. I can list the contents of the directory, again because I have read permission. But since I don't have write permission, here's an interesting thing. You notice file.txt is owned by me, but I can't get rid of the file. Not permitted. In order to remove or rename, which renaming is the mv or move command, can't do it. In order to do that, I have to have write permissions. So being that I do not have write permissions in the directory, that limits what I can do with files that I even own. And so just be aware of that. If you think you can do something because you own the file, but you're not being permitted to, well then it probably has to do with the directory permissions. And if this is confusing to you, maybe just watch this video again or read some other tutorials online, and you can learn a lot about Linux file system permissions. Now, what can I do with file.txt, though I do not have write permissions in the directory? What I can do is I can edit this file. And there is a built-in editor. It comes with Debian. Actually, it's Debian. I just learned that the other day. So Nano is the name of our file editor. It's like Notepad. And we'll go ahead and edit the file. And let's just fill it with some gibberish. If we want to save it, it is Control. We'll actually do the exit command, and it'll prompt us to save it. So this means Control X to exit. Save modified buffer. Type Y for yes. And then it gives us the option of deciding what file name. And it's the file we're editing, and so it just lists it by default. If you want to save it as a different file name, you can do that too. So we just hit enter, done. And it worked. Now you see it's 13 bytes. If we want to see what the file contains, we type cat. Like dog, but cat. And there you go. That's what we put into the file. So I have write permissions. That means I can write to the file. Could erase all the contents of the file. But because I don't have write permission to the directory, I can't delete the file, I can't move the file, or rename the file. And so just be aware of those things. If you own the directory and you own the file, and you have write permissions all around, then you can do whatever you want. All right, so we'll go ahead and remove. Actually, we can't do that. We have to become user. And since I was root already, I just type exit and I go back to the account I was in before. Now we can remove file.txt, go up a directory back to the root of the file system, and we can remove the directory. To remove a directory, you have to do rm for remove and then -r, and then the name of the folder, and it's gone. Okay, now I told you everything descends off of the /. That's the directory that's the highest you can get in Linux. Now we're going to learn a command called df. It gives you a lot of interesting information. And this will tell you how much of your hard drive or partition you have used. And it lists the other mounted partitions. Now you see quite a few things here. udev, which is the dev folder on the file system, that's full of, well, they're not really files. They are actually information about your system, and so that is actually a temporary file system. And so the rest of these are temporary file systems, the TMPFS. This one right here is actually my partition that I created that Linux lives on. And you notice these are 1K blocks, so 1 kilobyte. So these first 3 are kilobytes, these would be megabytes, and that would be gigabytes. And it tells you how many are used and how many are left. I've used 14% of the free space, and it's mounted as the root file system. If you want to look at it a little bit prettier, you do df-h or human readable, and it'll give it to you in megabytes and gigabytes. Now again, I say these are temporary file systems here. If you don't want to see those, df-h, if you want to see it pretty, we want to exclude the TMPFS, and we also want to exclude DEV, TMPFS. And that just gives us the one. I only have one partition on this system. And so this tells you where it lives on the file system. Every device on your system is put in this folder that Linux creates every time the computer boots up. And so that's where it lives. Now yours will be different depending on what you named it. If you use the logical volume manager, it'll look similar. If you did not, then it'll be different. It'll be like dev SDA1 or something like that. Okay, so we have our size here, 7.3 gig. We've used 963 meg, and we have 6 gig available. Now you may say, wait, 6 gig plus 963 meg is less than 7 gig, but our size is 7.3. How can that be? Well, the file system requires some space for file metadata, and so you don't actually get to use all of this size for files, and so that explains that. So you have to have a little bit of headroom, and that tells you where it's mounted. If you were to put in like a USB hard drive or a flash, like a memory card or different things like that, you'd have additional entries here when you execute this command. But since we don't, we just have this, and that's it right now. Okay, we've learned about the df command, and when we go back to trying to create folders, I'm going to go back to being the limited user account, and I'm in the root of the file system, and you see the permissions owned by root, and the world has read and execute permissions. And so since I don't have write permission, I can't, as user, make a folder in the root of the file system. So if I try making a folder, can't do it. And so I'm limited by the permissions of the directory I'm working in. Now, if I became root, well, then I can. Because I have the ability, I have the right permissions on this folder to do that operation. And so we're going to remove it. Now we're going to learn about another command that's very useful. You may wonder, where did all my free space go? You did the df command and you find out your root file system is almost full. You say, how can that be? Where did all that space go? du, not to be confused with df, du tells us the space, or it tells us where the space is in the different folders. It'll list every single subfolder relative to the directory you're working in. So if you do it as root, it's going to go on forever and ever and ever. There's a way to limit this. --max--depth equals 1. So it'll only go down one folder tree. And so there we go. Now these are listed in kilobytes. And so you see there's nothing in the media folder or the SRV folder, a few files in the temp folder, the var folder that has about 1/4 of a gigabyte, and then we have a few, again, these are not actually real files, but this is information you can find out about your processes that are currently running. Du cannot access it, and you're going to run into this error every so often, but that's not a problem because they're not real files, so I don't really care about anything in the proc folder. I can read everything else though. And so you can see in the user folder, we have about 0.4 gigabytes, the lib about 1/4 gig, and then the dot, this tells you where you ran it from, and so everything underneath the slash directory, which is the root of the file system, takes up 952 megabytes. Now if I were to go into the user folder and I want to get more information, where is all that space in that folder, I can do du, I'm going to do the max depth equals 1 again, and I'm going to tell it what directory I want to list, and that was the user directory. So there you go. Now we see that the user share folder's almost 200 meg and the user lib folder is about the same. And then again, the folder that we did this command under, we get the total at the bottom. One more thing I should list that's characteristic to Linux and not Windows is the fact that things are case sensitive. Your files and directories are case sensitive. So if I go ahead and create a file, test.txt, all lowercase, then I make one, I put a capital S in there and put a capital T in the extension, I can create them, and you'll see both files live here, and they coexist. Now Windows, you couldn't do this, you couldn't have them in the same folder, and so Linux is different in that everything is case sensitive, and so that's something to remember. It'll probably trip you up a little bit later. And so the easiest convention, and this is just the history of Linux, the default is just make everything lowercase, and then you won't have an issue. But something just to remember, and I'm going to go ahead and remove all those files. I'm going to do remove, then TE, and then a star. That star means anything. So TE followed by anything, which will get rid of test.txt and the other test.txt. And just to show you that that took effect, ls-al, and we're back to the way we were. So things are case sensitive. So we're going to recap a little bit. CD// is the root of the file system. If I do CD tilde, that takes me to my home folder, and pwd will tell you what your actual directory you're in is. pwd means present working directory, and you see we're in /root. If I do this as user, go into my home folder, pwd, every other user account is going to live in the home folder, and then the username of their user account as the subfolder. The exit command will get you out of, or going back to who you used to be logged in as, if you changed the account you're logged in as. We looked at hidden files. If it begins with a period, it's a hidden file, including the dot and double dot. ls will give you the directory listing. ls-a will give you the hidden files. ls-al, the L on the end, will give you the permission ownership, file size, file modification, all that information. We learned df. We learned df-h. That'll tell you how much of your partition is being used. You can also become another user by typing in su. That'll get you to become the root if you enter the root password. Or if you put in a user account, that's who you'll become. And if you're going from the root, you can go to any user account without having to enter a password. And then exit will get us out of being that user, back to who we were. If I go back and try the df command, you'll see why you want to run it as root. du rather, excuse me. This is why you want to run du as the root user, because you're going to get all these directories cannot be read because you don't have permissions to enter or to list the contents of those directories. So if you're going to use the du command, it's best to be root, or as you'll find out in the next lesson, you can use the sudo or super user do, and you can run just one command as root without actually logging in as root. Alright, so if we exit out of that, we become root again, and if we were to do the du-max depth equals 1 again, we don't get those read permission problems except for the proc folder, which those are not real files. If we exit again, that'll take us back to the login screen, and that's where we started. And so that'll end it for this tutorial. So hope you've learned something. Again, the internet is your friend if you need to learn more about file permissions. It's very different from Windows. It's one of the hardest things. It will take kind of a steep learning curve to get used to, but once you do, you learn it's very secure, it's very easy and logical to understand, and things are just better that way. So I think you'll learn to like it. So that'll do it for this tutorial, and I'll hope to catch you in the next one.